Okay, we're going to have a look at one of the most important, if not the most important idea in maths, the idea of the limit of a function. I'm going to do it by having a look at a sample question. It'll make a little bit more sense. It's probably the easiest way to explain it. So let's have a look at the question that we're going to do. So it says, as the value of x gets closer and closer to 3, what does the value of the function f of x equal to 2x minus 1 get closer to? So what this is saying is that we have values of x, and I'm going to draw a table over here. So our function that we're going to look at is f of x is equal to 2x minus 1, this function here. We have values of x, so I'm going to put a column for the x values here, and I'm going to put a column over here for the f of x values. So as the values of x get closer to 3, so what's going to happen with the x values is we're going to fill in certain x values into the function f of x equal to 2x minus 1, but those values of x that we fill in are going to get closer and closer to 3. So numbers like 1, 2, 2.5, 2.8, 2.9, 2.99, but we can go the other way as well, because you can get closer to 3 from, we could go 5, 4, 3.5, 3.1, 3.01. You know, we could get closer to 3 from both directions. And we're going to have a look then at what this function, what happens to this function, what happens to this value, the value of 2x minus 1, when the values of x get closer to 3. So I think when we do the example, it'll make a little bit more sense to you. So, okay, we're going to fill in values that get closer to 3. So we're going to start off with, say, when x is equal to 1. So when x is equal to 1, f of 1 would be 2 times 1 minus 1. So f of x would be 2 by 1 minus 1. Just fill in 1 into this function here, which would give us 2 by 1 is 2, minus 1 is 1. Okay, so let's get a little bit closer to 3. Let's say x is 2. So that means f of 2 would be 2 by 2 minus 1. So 2 by 2 is 4. 4 minus 1 is 3. So we can get a little bit closer to 3. We could go, say, x is 2.5. It's getting closer to 3 all the time. So we go 1, 2, 2.5. Always getting closer to 3. So 2 by 2.5. 2 by 2.5 minus 1. 2 by 2.5 is, what, 5? 5 minus 1 is 4. So we could get closer again to 3. We could go 2.9. So we have 2 by 2.9. So we just fill in 2.9 into this for x, minus 1. And what's that? 2 by 2.9 is 5.8, isn't it? Yes, it is. So 5.8 minus 1 will give us 4.8. If I fill in, okay, so let's fill in values getting closer to 3 from the other direction. So let's say we'll start off when x is 5. So when x is 5, f of x will be 2 by 5 minus 1. So 2 by 5 minus 1 is 10 minus 1, which gives us 9. Could get closer to 3 from this direction. So if, say, let x be equal to 4. So I got 2 by 4 minus 1. So I'm working out the value of the function every time for these values of x. So 2 by 4 minus 1 is 8 minus 1, which is 7. 2 by, let's say, what's another number closer to 3 going? We go 5, 4, let's say 3.5. So when x is 3.5, 2 by 3.5 minus 1, 7 minus 1, which is 6. Could go a little bit closer, so we could go 3 point, let's say 2. So 2 by 3.2 minus 1 is 3.2 by 2 is 6.4. 6.4 minus 1 is 5.4. And we could go a little bit closer even. We could keep going really close. I mean, here we stopped at 2.9. We could have gone 2.99, 2.999. Could have gone much closer to 3. So let's say we go, say, when x is 3.1, we get 2 by 3.1 minus 1, which is 6.2 minus 1, which is 5.2. Okay, so now let's have a look. The question again said, as the values of x get closer and closer to 3. So you can see the values of x here are getting closer and closer to 3. 1, 2, 2.5, 2.9. And they're getting closer to 3 from this side as well. So they're getting closer to 3 from this side as well. So they're getting closer to 3 like that, and they're getting closer to 3 like that. So as the values get closer and closer to 3, what happens to the function? What does the value of the function, so these are the values of the function, f of x, get closer to? So let's have a look. Now, so as the values get closer to 3, so we're going 1, the value of f of x is going 1, 3, 4, 4.8. Going from the other direction, it's going 9, 7, 6, 5.4, 5.2. So what's this value that they're getting closer and closer to all the time in here? And you can kind of see that the value is 5. So it's getting, f of x is getting closer to 5 in this direction, and it's getting closer to 5 in this direction. It never quite gets to 5, but it's getting closer and closer to it. So we can write that mathematically. We can say what we actually worked out there is the limit of the function. So we can write the limit of the function as x, as the value of x, and we write it down underneath, approaches. So x is getting closer and closer to 3, so we say x approaches 3, gets closer to 3, of 2x minus 1, and we say that that's equal to 5, because as the values of x get closer to 3, the value of f of x gets closer to 5. We usually shorten this word limit. We don't write limit, we sometimes write lim. So we always write lim usually. So the limit as x approaches 3 of 2x minus 1 is equal to 5. Sometimes you'll see it written, we won't write 2x minus 1, we'll actually write f of x, because f of x is 2x minus 1. So this would be the same as, it's equivalent to, the limit as x approaches 3 of f of x is equal to 5. So what we worked out there is the limit. So and we worked it out using a table. I'm going to show you in the next video a different way to work it out, but for the moment we're just going to work it out using a table. Let's have a look at one more example. Let's work out the limit. So we're going to we're going to find the limit, so lim, let's say as x approaches, say 4, and we'll go, so as the limit as x approaches 4 of, let me think, I'll just do a fairly straightforward one. We'll just say of 3x. So as the value of x gets closer and closer to 4, what happens to this? What happens to 3x? So our function this time is f of x equals 3x. So let's draw a table. We have our x values, and we'll have our f of x values. So f of x is equal to 3 times x. So we want to get values closer and closer to 4. So let's start off with x is equal to 1. So when x is equal to 1, 3x would be 3 times 1. So we have 3 times 1, which is 3. When x is equal to 2, we have 3x would be 3 times 2, which is 6. When x is equal to 3, we go 3 times x would be 3 times 3, which is 9. So you can see as the values are getting closer to 4, as they're increasing, the value of f of x also increases, but what does it get really close to? Let's fill in 3.5. So when x is 3.5, 3 by 3.5, just fill that in, 3 by 3.5 would be, well, 3 by 3 is 9, 3 by 0.5 is 1.5, so that'd be 10.5. So we're getting closer to something. Let's work the other way. So let's say when x is, we're going to work, let's say start off when x is 6. So when x is 6, 3 times x, so 3 by 6, value of f of x would be 18. When x is 5, we go 3 times 5, which is 15. When x can never be 4, so we'll go say 4.5. So when x is 4.5, 3 by 4.5, 4.5 would be 3 fours are 12, 3.5s are 1.5, so that would be what, 13.5. What else can we go? When x is, let's say, 4.1, we'd have 3 by 4.1, which would give us 3 fours are 12, so that'd be 12.3. So you can kind of see, it's hard to see what the limit is here. It was much easier in the previous one because we filled in a lot more values. We filled in values much closer. Remember, we were working out the limit as x approaches 3. So we filled in values much closer to 3, 2.9 and 3.1. So it was easy to see, you know, the value of f of x was between 4.8 and 5.2, so it's getting closer to 5. It's much easier to see. Here we haven't, we stopped at 3.5. So let's fill in another value on this side. Let's go, say, 3.9. So when x is 3.9, f of x would be 3 times 3.9. So 3 by 3.9 would be, okay, let's work it out. So 3 3s are 9, 3 9s are 27, so 9 plus 2.7 would give us 9, 10, 11, 11.7. 11.7. So now it's a little bit easier to see. When we could fill in another value, we could fill in 3.99 and we could fill in, say, 4.05 or 4.01, much closer to 4. But if you look here, what's the number that's squashed in between 11.7 and 12.3? What's going to happen if we keep getting these numbers closer to 3? Keep getting them closer to 3, or sorry, closer to 4. Well, what will happen is that the limit of the function, 3 times x, will get much closer to the number 12. You can see it in here. So the limit, we write, as x approaches 4, of the function 3x is equal to 12. Okay? So in both cases, in both examples, we worked it out. We worked out the limit by drawing a table. In the next video, I'm going to show you, we're going to use a theorem, and I'm going to show you a much more accurate way to work out the limit. A much easier way where you don't have to draw a table, and a way that works out much more accurately.